Welcome to the final session of the 5-day faculty development program in Internet of Things at IIT Goa. So this is the valedictory session. So initially we will have a short interaction with Professor Bidyadhar Subudhi regarding the role of research and development in engineering education. And you can also ask him questions, a few questions related to R&D funding, how to write R&D proposals and things like that. And then thereafter, we have our keynote speaker for the day, Mr. Dham. He is from R, so we will have a talk by him. And then towards the end, I will have an interaction with all of you regarding the FTP. So on behalf of myself, IIT Goa, and all of you here, I would like to welcome Professor Bidyadhar Subudhi as the guest of honor for this valedictory function. And some of you who attended the opening ceremony, you might remember him. He gave a very nice and broad overview of the Internet of Things. So he is a professor in electrical engineering at IIT Goa, and he is also the dean of R&D at IIT Goa. He holds a PhD from University of Sheffield, and he is very active in research and development related activities. So welcome, Professor Subudhi, and over to you.
Thank you, Professor Sharad, for inviting me to this session and to spend some time with you and your team, because I believe that you built up a team for the last 5 days, and I get an opportunity to discuss with them. And as you mentioned that R&D is an important component of in the career path of any professional, particularly the academician. Now, first of all, why do go for research? What is the need of doing research? Basically, there are some sort of confusion. People think that either I go for teaching or I go for research, but why both together? Because they are complementary. They complement each other. In the sense, suppose you teach in the class and you don't go for research, and you never know what is happening elsewhere, and your own experience you cannot bring into your teaching. So in order to reinforce your teaching or to make it more strengthened, obviously research is necessary for the academician, the first part. And the second obvious question is, the promotion is directly related to your publication, projects. So all the P's are very vital, PhD, guidance, research publications, and patents, then projects, maybe professional outreach, and all these count in your career path. So therefore, we need to have research, and if you are a faculty, it is more required now ever before. The reason is that compared to the earlier days, we are also fortunate to have many resources than earlier days. I don't know whether you know it or not, my professors tell in the class, when they started their research, they have to take their punch cards, go to the machine and put this data and get the results later on after 1 or 2 days. But we are all fortunate that we have our own laptops and many computing devices available to us. And we have many search engines for browsing the research publication that arose throughout the globe very quickly. And therefore, our research having all these inputs, we need to expect much more things to happen. So what is the much more things to happen? What I mean by that, because simply by doing research and publishing the papers is not sufficient. We should, time has come that your research should lead to a product or something like, what is beneficial for the society or the mankind in the long run. So therefore, the government has now initiated particularly the more, involvement in the startups, in the patents. So therefore, publication in the good journals and going for a patent, and also opening a startup. So all these are now in your career path. You should list them 1, 2, 3, 4, etc. And also guiding a PhD is also important. Why? Because once you guide a PhD, it will build a confidence that how you will go for an independent research. You can build a research alone, and you can extend it to a team. So your student and you then gradually evolve, and then cycle grows, and then you will be recognized as one of the contributors in your area, and then you would have opportunity to collaborate with the different collaborating agencies, maybe with the industries, maybe R&D organizations. You might be knowing that in the recent days, particularly some of the organizations, the funding agencies like BRNS, DRDO, they mention that while you apply for a sponsored project, so you need to establish that in what way your research will be beneficial to that industry, or the so therefore you have to find a collaborator from the industry before you submit a proposal. And if you have something in your mind and then you fine tune it depending upon the need of that industry, then you submit that proposal. So while doing so, then at the end, the industry may expect that in what way your research will be beneficial for that industry. So what I am interested to give a message here, that we all academicians now, our job is not limited to only teaching. We also are involved in research, and not only the academic research. The earlier research was only limited to academic research, the incremental research. That means if you browse some papers, then some area is given and tune it to some other method, some other algorithm, and come up with a paper. It's not the requirement now. What it is required, you try to, in your real life, you are all running out of the problem. So when there is a problem, we are all afraid. But in the research life, we are running after the problem. So that means your problem formulation is okay, then there is a solution. If it is a solvable problem, then your research begins in the right direction. So therefore, you know that when you guide a PhD student, so always you talk about whether your problem formulation is done. That means the first step towards doing the research is the problem formulation. So therefore, so how to formulate a problem? So therefore, we need to have some kind of research review. You should know how to place your work and where you can contribute. So then, but more importantly, when we do a research that leads to a product or helping the mankind or increasing the productivity of industry, but we should not forget about the honest attitude that we should adopt for involvement or contributing towards the research. That means, like, if we steal somebody's property, it is considered to be a theft. Similarly, when we do a research, we must not claim the kind of contribution that has been reported by elsewhere in any literature. So therefore, if you want to refer something, you try to give the credit with some kind of reference, or even if your own publication, if you take it there, so it would be considered as a plagiarism. So now it is any publication you submit, publisher, any journal you submit or any book proposal you submit. Now the editors are very smart enough. They use the kind of copyright, the plagiarism test softwares like Turnitin, Urkun, etc. So then they know that how much you copied from your own paper even. So then on that basis it is rejected. Even a thesis today, that should be also free from your, like, there is a certain level of similarity. That means you should ensure that more work level you should contribute rather than taking somebody's work. If you are really referring to somebody's work, you should give due credit to that, and you should, because many of the research contributors, they think that doing something and publishing it is your only contribution. It is also true that when you try to narrate the research, you have to express the entire research area in your own research background in your own words. So there, while doing so, you should keep in mind that how best you understand that, not copying and pasting something in your publication. And then another important is that your kind of choosing a right journal. Nowadays, now the paid journals are coming up. So therefore, we need to discourage people who publish in the paid journal. There is no need of publishing so many things. You publish less, but those should be in ACI journals or good journals. Then that will fetch you good career growth in future. So then I think, Professor Sharad, how much time is left for me?
Maybe 2-3 more minutes.
Okay, so I will wind up 2 to 3 minutes. So then another important thing is that that is your the citation. So how your citation impacts your career? Like all of you know that the H index, I-10 index, all of these parameters are greatly influencing your career path. So what happens that how many, let us say the last 10 the journals or publication you make, how many of them contribute or have citations more than 10? So that is the I-10 index. Similarly, H index, with how many how many of your papers have been appreciated by the others or referred by the others over the last couple of years. So therefore, these H index and the I-10 index are very important factors. And we have different, like we have the ORCID and we have the Google citations. So many things are there. So in order to really make a good career, so I urge all of the participants that you spend some time, think carefully, and build your career, research career in a way that you should have impact on your research. That many people, when they refer your paper, you really feel that I have contributed something. If I have published, let us say, 300 papers and none of them are being referred by others, no use of it. So therefore, less it is a question of people say that I have 300 or 400 publications. Truly, it is not required. Even if you have 5 publications or 10 publications, but they have some thing to do with delta contribution in your research area, and some of them are translating your ideas to solve some kind of problems that is happening in the recent days. For example, the COVID situation has opened the door for many researchers in the recent days. So if you have really applied your knowledge to contribute to help the nation in solving some problem, that is really, one should salute to that. So I believe that your participation in this wonderful institute and by this wonderful coordinator, Professor Sharad, has made your life very enjoyable in the cloud environment. I believe if you would have been free from COVID, you would have really enjoyed our hospitalities, and your participation would have been much appreciated in terms of the Goan kind of food, Goan kind of tourism, many more things. And nevertheless, as soon as the COVID is over, I believe that Professor Sharad will not leave any stone unturned to make it a real life or real participation instead of a virtual participation in the future. And with this, I wish that all the participants with a bright future in terms of their academics and nourishing their career in the research progression. And I hope this IoT has opened their life in a way that they will bring real kind of contribution in their profession, and in the end the benefit that will benefit the whole human society. Thank you all. Thank you, Professor Sharad.
Thank you, Professor Subudhi, for that very nice, for sharing your thoughts on research and how research shapes one's careers and teaching and those aspects. And indeed, once the COVID situation improves, we will have in-person FDPs so that people can come to Goa, enjoy the hospitality in IIT Goa, and while they learn new concepts and new things. So we have time for a couple of questions. So if any of the participants have any questions related to research and development, please feel free to ask. Yes, Pranav.
Good afternoon, sir. Am I audible?
Yeah, you are audible.
Sir, my question is that if I'm having some research idea, or if I'm working on a prototype, and if I want to launch it as a product for the betterment of society, then can you, is there any resource where I can look for the investors? Like, is there any website, or is there in a group of people which can I refer to provide the funding to a particular project?
Yeah, that is a very good, yeah, I appreciate your question that, okay, if you have something you have designed and you have a product, and then my first suggestion to you is that you file a patent. Okay. So there are patent agents, IPR activity there, and every, big city there is a patent, office is there, and you can submit a patent, and as soon as the patent is granted, you can commercialize it. That is the one way to do. And also now you can open your own startups, so you can register as a startup company, and you can promise some more thing to do, and this one product can if it is really beneficial for something, so you can start a multi multiple products you can think of, and you can always you are always encouraged to open a startup to make more progress in the direction. Am I okay to your answer, or do you need some further clarification? So there is a question: are there any free SCI publication? How to approach? Are there free SCI? What do you mean by free SCI publication? That means unpaid. The free means you want to publish, or you want to get the access to read that paper. Which one you are meaning? So if you want to have the free SCI means the publication is free you are talking about, or to access unpaid publication? Yes, many of the publications are unpaid. So because there are some publication which they ask for the, because there are two modes. One is the subscription mode, the other is the the copyright mode, open access mode. So it is your choice. If you want to make it more people to see instead of only the subscribers, you can always go through the open access. It's not that all the open access journals are bad. Even some of the nature journals are open access journals. So therefore, it is your choice whether you want to make it more people to go through, because when it is open access, that reach many people to look into. But if it is a subscription mode, only those institutes they subscribe the journal, they are only free to see. Others are not able to see. And regarding publishing in ACI journal, I prefer that you can always see that the best journal depending upon their impact factors, and also the you can review there from their site that how much time they take to publish the journal. Because if some journal take more time, let us say 2 years time, there is no need of publishing in those journals. And seriously, if I look, I think most of you are in the same community where I am, I believe, like the computer science, electrical, all of them fall in one bracket. So like IEEE journals, or ACM journals, or Elsevier journals, or Springer journals, or Wiley journals, those are considered to be the good places where you can submit your papers.
Okay. So there is one more question which is related to startups. So in the interest of time, Anurag, I will just answer that question, that you can find such details at Startup India website, which is a government of India website. So if you just search for Startup India in Google, you will see that you will get the link to that website. It has all the information on how to register a startup, where to register, etc. Okay. Okay. So okay, then I think let's move ahead with the program. So Professor Subudhi, once again, thank you for sharing your thoughts and also for answering the questions of the participants. I hope the thoughts that you have shared, that will trigger some more questions in their minds, and they can they can find, you can also find Professor Subudhi online. So if you just search for him in Google, you will find him. He is one of the top 2% researchers in electrical engineering, especially in controls in the country, and he also holds high international ranking. So it's very easy to find his contact details if you wish. Okay, so so thank you, Professor Subudhi, once again for the interaction.
Thank you, Professor.
And we will move ahead with the next stage of this session. So we have with us Mr. Ish Dham. He is the keynote speaker for the day. So before he starts, let me introduce him to all of you. So Ish is a distinguished engineer at R. And for those of you who are not familiar with this kind of positions in industry, a distinguished engineer or a fellow of, say, Intel, those positions are coveted positions in those companies, especially those who work in the engineering domain. So Ish is one of those engineers, distinguished engineers at ARM in the architecture and technology group. With a background in computer science, Ish comes with a strong passion for computer architecture. He has been involved in the design and validation of high quality processors and system on chips spanning multiple domains. Currently, Ish is driving the machine readable specifications strategy for ARM architecture. As part of this strategy, ARM is endeavoring to provide as much of the specification as possible in a structured machine readable fashion besides the standard document format. Through this, ARM hopes to enable innovation in both hardware and software design that relies on accurate interpretation of the architecture. So welcome Ish to the session. Can you hear me?
Yeah, thank you so much, Sharad. Thanks very much for the kind introduction. Am I coming across all right?
Yes. You are visible. You are audible. Please go ahead. Over to you, Ish.
All right. Okay. So thanks, Dr. Sharad, for providing me this opportunity to talk about some of the aspects around the IoT systems. My system is indicating a bad network connection. Should I try to switch network or it's okay?
I think it's okay. At least to me, it sounds fine.
All right. Okay. So I was IoT is an area which I find very interesting, but I'm not very directly involved. The aspects I thought that would be very useful to kind of talk about would be some level of end-to-end thinking, especially around security. So that's what I will be attempting to share here. Feel free to stop me at any point of time to raise any queries. You could raise hand or kind of interrupt in, and we can have this kind of go on. I've tried to keep it as a simple conversation, and hopefully it's valuable for all of us. I certainly enjoyed putting it together. So when it comes down to security, I'm sure you've been having this course on FTP. There would be parts on doing threat analysis, and one of the key techniques that is used for threat analysis is the stride-based analysis. You look for where there may be spoofing, tampering, repudiation, information disclosure, denial of service, or elevation of privilege. But the key thing is, what is all this on? So typically you look at what is the function you're trying to do. And then the other key aspects is the assets, right? What is this information that you're trying to secure? What are your secure assets that you're trying to manage, right? And that's a simple concept. It can be applied very powerfully to analyze almost any of the security related aspects there. The key with IoT though is, where is this function, right? Is this function sitting on the endpoint, a device that we are using and running, or is this function sitting on the cloud? We all love to talk about things on the cloud, and it's thanks to this cloud computing and connectivity that we are able to have this FTP in this format today. Is it in the cloud, or is it on the edge? That is, some computing that is in between this endpoint to the cloud. And the thing with IoT especially is that this boundary starts to blur out, right? I mean, that's the whole idea of this connected world, that you start having this boundary kind of blur out. And I mean, to illustrate this, let's take an example. About a year ago, my mom had some condition, and then doctor said that we need to be connecting her to a Holter, a test device, which is something that's a continuous ECG monitor that you can wear for a few days, go about your business, and then it'll record how your heart is functioning over all this period of time, and then doctors can analyze and see if there are any abnormalities and so on. Now, if you have such a device, these are pretty simple, small devices that you can put on. I mean, the one you see in this picture is relatively bulky by comparison. You would typically, this sort of device would connect out to a cell phone that you may be carrying, that they may provide, or your own cell phone, and through the cell phone it may connect to the cloud over the cellular network or over Wi-Fi, and as need be, the medical facility that is supporting this could get alerts saying, hey, there seems to be a challenge, maybe there is an emergency that needs some attention, or they could review this data, and at the end of this study they could download this data and analyze it and come to conclusions on how things are functioning. So it's a nice piece of technology that kind of illustrates all of the aspects of what happens on an endpoint, the collection device, which is clearly an endpoint piece, an edge piece, which is typically a cell phone, but it could be something else, or maybe this is also able to get onto the cloud directly. Things on the cloud, which is able to process this and then be able to kind of have it, right? And if we then try to step back and analyze where is this function kind of running, it's interesting to see that there are a range of choices that are possible, right? In this function, what you're kind of having is it's measuring the ECG. What's shown here is a normal rhythm. What it tries to alert for or look for is some errors within here. So here you can see that there is some some distortion in the rhythm that you want to kind of catch out and be able to detect it and so on, right? So the key is, what do you do, right? You could have a system where there's this device that is completely standalone. It is not connected, at least not on a continuous basis. It stores all the information, with the kind of storage that is available these days, you could easily store days worth of information on a device. And you can retrieve it by putting a physical connection. You connect in a USB, make a connection, download the information, and you analyze it, right? So that's a typical thing that's possible. That's how most of the systems end up working today, in some sense. It could be connected, and you could be having all of the processing happening on the cloud at the other end as an extreme side of the things. You could be having other intermediate side of things wherein you're connected to the cell phone. All the processing happens on the cell phone, and the cell phone sends out alerts. You could be having processing on the device, and as and how there are any concerns, you send out alerts to the edge device, and then that can relay an alert to the healthcare system. Or you could have a completely autonomous device where you do the processing on the device. The device is directly connected to the cellular network, so there is no need for the patient to be carrying around a cell phone and so on. And this can all directly kind of be reaching out and be dealing with the things, right? And while all these choices are there, it is useful to consider, what do these choices do to the capabilities that you get? I mean, clearly in a not connected system, it is impossible to get real-time alerts going back to the healthcare provider in that context. In much of the others, those aspects are possible. But what does it do to the battery life of your endpoint or on your edge device, right? So supposing if you said that you do all your processing on the cell phone, then on a continuous basis, you need to be sending all the information that you're gathering on the cell phone. So you're going to pay the cost of transmitting, the power necessary and the compute necessary to be doing the transmitting on a relatively continuous basis. And the cell phone has to be largely on all the while trying to receive it, right? And being processing it on a relatively continuous basis. So if your goal was that you should be able to raise an alert within 30 seconds, then at least once in 30 seconds, the cell phone needs to, download the data, be processing it, and be doing the things there. Now, cell phones are wonderful devices that, can last for, over a day of working, but they are designed to do that by being off most of the time, right? They go into idle state when you're sleeping and so on. Your battery meter does not move as much, right? But if you have this sort of a real-time requirement of continuously downloading data, processing it, and so on, what would that do to your battery life of your cell phone, right? Of your edge device in that sense, right? Or of other side of the things there. Now, this is something approaching it from a capability perspective. What about from a security perspective, right? So if we, if we go back onto our stride, a key care about that most people trying to seek health related connectivity is privacy, right? I mean, like all the debate that has been going around related to the Arogya Setu app and so on. When it comes down to health, you want the connectivity, but you also want the privacy, right? So when you are downloading all of your data and making it available on further away from the body, then you constantly run the risk that what if that data is used besides providing the quality of health that this is meant to provide. What if somebody is using, for example, to detect what kind of activity I am doing, right? So I'm wearing this device having all this connectivity, and then somebody at the other end is able to assess how I go about my day, how I go through various excitements or whatever else, or even maybe correlate to IPL matches going on, and which team I'm potentially supporting or not, by seeing how my heart rhythm is going based on how how the things might be correlating out. These might be possible to detect even though I'm not participating in that sort of an exercise, right? So there is a lot that becomes possible the moment you say that this data is kind of made available on a more distant sort of an aspect, and there may be the security side of it. Now, while the most useful form of security in this case might be privacy concerns, there can also be other aspects coming in, like reputation and so on. When I am if I'm wearing this device to support a large insurance that I'm trying to take, which requires me to go through this sort of a test, then of course the insurance provider wants some assurance that the data is coming from me and not from somebody else and so on, right? So how do you kind of go about establishing these this sort of reliability of the data and the aspects there? So it's with the function spanning the endpoint to edge to cloud, you can see that in IoT the scenarios are very varied, and there are a lot of possibilities, and the possibilities have different functional implications. What will survive a network glitch, right, or a network breakdown for some period of time, or if I am there in a little bit of a remote area for 5 hours or taking a flight or something, what mechanism can survive that sort of an aspect is one thing, or availability of service and continuity of that. But it is also then having trade-offs in terms of security that start to come in interesting ways, right? So clearly, I think from basically what I said, you can clearly come to a reasonable conclusion that if you had a way in which you could, on the device that you're wearing, if you could do the analysis and send out alerts, you might be able to get both quality of service. You might be able to get better battery life and continuity and everything else, and you might be able to get better security as well, right, at the same time, from privacy and at least some of those concerns in some ways. Now the key thing becomes, hey, can you have something that is battery operated, which is going to be able to do this kind of analysis on a continuous basis and be able to sustain it in some ways? And there are a lot of technologies today that can enable that. So it is indeed possible to have, I mean, of course, it is certainly possible to do this kind of a compute by strapping a laptop on you, but that's not necessarily what you want. You could strap a full cell phone on your body and be able to achieve something like that, but that may not be very right from a cost perspective, right? And it also would need a very large battery and everything else. But you can indeed have a lot of embedded capabilities that make this possible. There are many aspects that make it, I mean, this sort of an application should be possible on a relatively small processor itself, depending on how far you want to go on your analysis. But what I wanted to kind of show is, increasingly these days, there are technologies emerging that allow you to leapfrog performance on certain aspects like in the recent has been is something that makes a significant shift in performance on what is possible for machine learning, for neural network processing, and for DSP kind of processing in some ways, right? So that's one of the things that kind of becomes a method that becomes possible, that can shift things towards being able to do things at the endpoint. Now, the key to kind of also think of is, where should you look to kind of do the things there, right? Should you always be looking to shift as much as possible towards the endpoint, or are there other choices that make sense, right? So clearly, for doing something like the alert generation for AFib, it is useful to do the detection closer to the endpoint, right? But that same place may not be the best suitable to place your medical history, which is also related in this context, right? Now, that endpoint may not have access to all of your medical data, and it may not be an efficient and quality way to be able to do so, right? Maybe it's sensible that the medical history is there on the cloud and the AFib detection happens on the endpoint, right? So, I mean, I think the key point being that a single choice or a trade-off is not necessarily the most useful way of being able to approach it. The use cases need careful attention and analysis to make this determination and be able to do the things out in some ways, right? Now, we talked of one aspect, which is essentially, you have a function. That function could be sitting on the cloud, could be on the edge, could be on the endpoint. But another key aspect that's true with the connected world is that you invariably don't have a single function that's operating on a device or a set of devices or on a system. You typically have multiple functions with multiple assets being there, right? And these functions may also have some level of interaction between them. But if you're not very careful, these functions could start to impinge upon the other functions as well, right? So availability of these functions. So I'm having these health devices. I'm sharing this data through my cell phone, but my cell phone also has some video play application, and that video play application is able to steal away my health data in some sense, right? Or maybe I have a temperature measurement sensor also, which is really not having or maybe I'm having something for recreational purposes, which I'm not seeing as having any sensitive data, but that application could be impinging on taking away some more private and critical data and so on, right? So the moment you start having multiple functions coexisting, whether on endpoints or edge or cloud and things in between, these can impose threats on the other functions as well. And it becomes, that is one of the really important things to be able to do, to be able to isolate these functions so that they are, you are able to get your security guarantees and be able to kind of process out and so on there. And there's probably many ways to potentially achieve that. I mean, one of the things that you can be kind of looking at is how, is can you have a single device that is relatively low cost and is still able to make this isolation of, domains and functions possible, right? And so you can clearly do this by having multiple devices. You could be having two Cortex M's or some other devices that are there that are carrying these functions more independently. Or you may actually benefit from the fact that you're able to run multiple of these functions on the same device and yet be able to bring a quality isolation between them, right? There's many technologies available in this space, and clearly it isn't very useful to kind of put in multiple devices all the while to be able to do the things there. One of the technologies that we have is having trust zone based isolation that could come about. So similarly, virtualization is another technology that is there to be able to make such a thing possible on fairly low cost devices. Probably this trust zone sort of technology is a very powerful technology to be able to achieve this kind of isolation. And what this is able to do, I mean, this is something that we have in ARM introduced only more recently, and with the expansion of the IoT side of things. What this is able to do is to have essentially be able to have a coexistence of two views on a device at the same time. We call that the non-secure view and the secure view, right? And the idea is by having these two partitions that are there and having these good methods to be able to make these partitions in a very formal way, you are then having a capability to kind of achieve whatever end goals that you want to kind of do. Now at a hardware level, what we kind of enable is to make these two partitions possible, to have a non-secure view and a secure view. And the idea is that you would kind of keep a lot of the secure data on the secure side of it, the things that manage the stuff, the stuff that manages the keys and so on. You would be managing it on a secure partition side, and your applications and so on might be running on the non-secure side. But it is interesting to note that you could utilize this partition once it's available to actually build multiple partitions as well, if you like, right? So what you can be doing is to have these different non-secure application partitions that you can switch using this secure partition and be able to have a high confidence that the two non-secure partitions are not able to isolate on, right? So the solutions are never just here is this one piece of hardware and that kind of achieves in the end systems need to be typically achieved by a mix of hardware software solutions and building out a stack of capabilities that build on some simple aspects that can be proven, and then on top of that, then you could be having higher level of capabilities coming about, right? So what trust zone enables is to be able to do this efficient isolation in a standardized way without incurring significant costs. I mean, typically, virtualization and so on would be a significantly high cost system that is there with a lot of developer aspects and so on that are available. I'm not going into the details of how this architecture works out, but it is something that is available to be able to make a switch between the non-secure and the secure side merely by being able to do a function call, right? So you can do real-time performance and be able to do these switches with a very minimal hardware costs of being able to do that. So that once it becomes possible, now let's kind of maybe try and see in a little bit of a realistic situation on how something like that could kind of deploy in, right? So let's say if you were having an IoT system, I mean, a typical IoT system, you need a form of connectivity for sure, right? I mean, otherwise it is not really otherwise it's not really an IoT system. You need the processing, you need the sensors and so on, right? So you could be having a typical simple system where you're having a separate modem, a dedicated low power isolated modem that is there, a processing system, and then all the peripherals and flash and so on that's able to kind of operate out, right? You could be using you could be utilizing the isolation in this case to bring about the root of trust and all of those sort of aspects out and being able to manage the things out in that way, right? But if you had, I mean, there's another sort of system that you could have where you make the modem side of it actually even thinner in terms of hardware, and you push some of the modem functionality onto the processor now, right? So your processor is starting to do some level of the processing there, so maybe that thereby you're able to lower some level of cost, but you're also able to get some level of flexibility because now you're able to upgrade these in software and so on, right? So when you have that, then you may be further benefited from being able to do an isolation between the host, the application side of the function and the modem kind of the function, and be able to do that separation and be able to deal with the things there in some sense, right? And further on, if your system demanded more performance, right, and it is not feasible for a single processor to deal with both of these loads, maybe you really want to kind of look at a separate subsystems where the modem is still programmable but is managed by a separate processor, and host capabilities are happening about on very separate side of things. The idea being, I mean, effectively both from the previous example and this one, what I really want to kind of highlight out is that for the same real application, right, depending on looking at the trade-offs, a range of possibilities are are available, right? And you may want to kind of scale onto different side of the things depending on what the application demands, what the system sort of needs, and so on. And clearly, a single style of implementation is not suitable to be able to meet the goals and needs and so on. Now, once we are able to kind of do these and have have systems that are able to work, how do we really go about analyzing whether we are able to meet our security needs and so on in that sense, right? And this is really fundamental to building the modern day IoT systems. It's one thing to be able to realize the functionality. It is another to be able to provide the assurance of appropriate security that is necessary for this to be possible, because the threat models kind of extend out on the stuff there. So trust becomes a really important element of being able to build the devices. How do you when you are processing some data, how do you trust that the data is genuine and has not been tampered with, plus also cannot be stolen and so on, and your assets are kind of being able to do that. So that becomes a really important aspect. One of the ways I mean, and this is true, regardless of what kind of application we are trying to be able to service. I mean, this page puts out, a series of applications of just about every kind that you can think of. And, it's just trying to see, is it valuable for the application to be connected? And, clearly most applications, there is some value on having connected side of things, maybe not the coffee maker, perhaps. Upgradability is another significantly important piece. It is not easily possible to just build something and have it run its lifetime without needing to be upgraded, unless it is a small disposable short life cycle kind of an aspect, right? So most applications end up needing upgrading capabilities. The things that don't either are probably short life cycle or very fixed function in some sense, right? And in many cases, there is some or the other high value information being managed. Like the healthcare application we talked about, the healthcare information is clearly an important asset that you're trying to deal with. And most applications also have key performance requirements or performance and power requirements that are interesting and important to juggle out, right? So it is not easily possible to think of new designs that are not connected or don't require security in some ways, right? Now, in order to facilitate this, the analysis and working and deployment of secure side of things, one of the initiatives that ARM has come up with is the platform security architecture called PSA. It's an architecture that is deployable regardless of the regardless of the implementation architecture. So it is not tied to ARM in any way. It can be utilized on any system, really. It establishes out a series of steps, and these are available in the open. So there is PSA certified.org, where you can see the details of the PSA certification and the PSA platform security architecture itself. The key aspect it highlights out is to kind of do a 4-stage design, to go through an analysis to understand the threat model. What is your system? What might be the vulnerabilities? How what are the secure functions? What are the secure assets, and so on. So that is fundamentally very important to kind of analyze out. I mean, like we were talking about in our health system, at least at some level of things, that's kind of important. Stage 2, you look into architecting a solution, looking into hardware and firmware specifications and choices that will kind of enable the things out, implementing it in stage 3. And there, I mean, depending on what you're trying to do with it, if you're trying to go for broader deployment, then you may want to have it certified, and it's possible to go through different levels of certification. The simplest of levels is merely a checklist sort of thing, where you do a self-certification looking at various details. And so it's a form of a checklist that enables the things there, to something that is supported by lab analysis and so on, which can then provide an assurance for people who are consuming those devices or systems and so on, to be able to do the things there. So it's not something that is prescriptive. It's more of a framework. It is open, and it allows for making right size choices in that process, going through the pieces and being able to do the stuff there. All of this is based around security goals. So there are 10 key goals that have been identified, and these are applicable in any system, really, any electronic system that is aiming at IoT or even non-IoT kind of systems that are sort of there, but connected systems. And the 10 goals, very briefly, are, every device needs to be uniquely identifiable. So you can't really be talking of security if you're talking of anonymous entities, really. So you need to be able to uniquely identify a device. There is the security life cycle that is very important with the, you have all the secure assets that are a function of the hardware, the firmware, all the software, and so on that is there. The whole process of manufacturing and making the system available and deployable has a security life cycle. From that point to even the point you come to where you discard the system, there is a life cycle that needs to be kind of understood and analyzed and seen. So that is something that is important. When you say a system has certain capabilities, those ought to be attestable, right? So when we say, somebody has received a degree, finally we value the fact that somebody has a certificate that has been signed by a, dean of a registrar of a university saying, we assure that this person has, fulfilled these criteria. So there is an attestation that is important. I mean, otherwise anyone can be laying some claims on, how that's kind of happening about. So that's key. How the system kind of comes to life and establishes a root of trust, and then builds on it and makes that root of trust available through the device, through the application, and so on, and continuing to provide it. That is really, really key, right? And so that's where the secure boot, or that's an important part of the life cycle in terms of the things coming on to. So essentially, the key thing is that you should only be running what you trust, right? Or if you don't trust, then that is, appropriately accounted for from the threat model perspective, and that's a very key property that is important, that you're having a secure system and you're running a secure software on top of it, and so you're overall having a secure system that you can trust, right? The other bit that is really important for most connected systems, especially with a reasonable lifespan, is it should be possible to make secure updates, right? So you cannot be imagining, no matter how well you design things, there will be vulnerabilities that come about, right? And one of the leading ways of being able to manage the vulnerabilities in lieu of replacing that device is to be able to update, make security updates and be able to do the things there. So, upgradability, updatability is really, really important. And when you have done that, it is important that people can't just turn the knob back, right? So you figured you had some flaws, you put in, an updated firmware, and somebody came in and said, this is just not working that great. I like my old this thing, and just turned the firmware back to an older version, either out of this sort of a performance requirement or out of, as a way of subverting things and so on. So it is really important that, you're able to update, but you also have a ratchet that prevents you from being able to roll back and start exploiting the older vulnerabilities and so on. And then depending on, like we talked about the multiple functions coexisting, it is important that these functions are appropriately isolated. And this is assured and brought about. It's not very useful if you just have multiple functions, if those functions aren't able to make interactions, right? I mean, maybe you are having these multiple functions just to be able to use the device capabilities and have those. Maybe that's useful to a certain degree, but usually there is value in these functions being able to exchange some information, being able to interact amongst each other. And those interactions should be possible to do in a secure way. I mean, that's quite important. You would have secure assets in digital devices. Secure assets are typically secure information. You need to be able to manage that information in a secure way, so secure storage, and then you may need to, make communication on a on untrusted channels and so on. So being able to do cryptographic services, trusted services for a variety of reasons, for doing upgrades, for doing other aspects and so on, is really important out. So there are these 10 broad goals. These goals are not tied in any way to ARM architecture. They are broadly applicable, and they form the goals of the platform security architecture, and then the aspects are built on top of it, and kind of the things there. So that's a reasonable way of probably approaching the security considerations in a system. In summary, one of the key things that IoT does is it blurs the boundary of where the assets are stored and the functionality is realized, right, between the endpoint, the edge, and the cloud side of things, right. The security is really important in all these systems, but you can't do security as an after the fact side of things, saying, okay, I'll build a performance system and then I will figure out how to make it secure. It doesn't quite work that way. You really need to think of security up front, right? Like in that PSA steps, in the stage one, you need to do your analysis and have your answers available to be able to take it forward into design. Security is very hard to retrofit in some sense, right? There is no single answer. So for a variety of reasons, I mean, whether it is for security or to get performance, cost, and so on, there are, engineering is all about making trade-offs, and these trade-offs need careful analysis. Like we saw with that, modem and host kind of functionality, for the very same application, depending on, the power performance aspect that is being targeted, different solutions might be relevant from that perspective and so on. And in this whole connected world, you also need the connected solutions. So it's not sensibly possible for one person to just think of the whole stack and kind of take care of things. So having, building on established principles and framework, like the PSA side of things, or whatever the frameworks be that you're trying to be able to utilize out, having proven frameworks and building on top of that is really key to being able to build the security out and be able to get to the stuff there. So that's basically what I had in this context. Hopefully, I was able to share some level of appreciation on approaching the IoT systems from an end-to-end thing. I'm sure the program had covered a lot of these aspects as well. So that's the bit that I had. Any questions or comments? I'm happy to take at this time.
So any questions from participants? So maybe I'll begin with one quick question.
Sure.
So very often, it is seen that security is seen as an add-on, something to be added on top of the design. And what you have mentioned very clearly on the summary slide is that it needs upfront analysis. So why do you think that designers tend to ignore security, or it is not really ingrained perhaps in the way we teach systems design or architecture or something like that?
Well, I mean, a lot of the focus is usually on the use case, right? I want to do something. I want to make I want to make that continuous ECG, or whatever it is that I am trying to do. And a lot of the engineering focus, a lot of the times in terms of design, is on building that piece of functionality. And there is this view that, okay, if it needs to be secure, we'll just take care of it as an afterthought. But clearly, once you make some of these decisions and choices, you can't easily undo them, right? So if you have decided where you are going to do your computation, you can't suddenly shift it. I mean, if you in that example, if you wanted to now shift some of the computation that you wanted to do on a cell phone to the device, you may find that your device is no longer capable of being able to do that, right? So it is not, I mean, in that sense, it's not easily possible to sometimes, continue even the functional realization when you try to put the security in. And the other aspect that comes in that is, harder to kind of, it's easy to miss is, security builds up on trust, right? So you have a trusted system on which you put more trusted bits on, and you maintain your trust, right? If you have a foundation that is not very trustworthy, right, like they say, right, you can put the best lock on your door, but if you have left your back door open, you're really not got that capability, right? So a lot of the times we are focused on building a strong door and a very good lock, right? But we don't realize that we have left windows open, and there are back doors available and everything else. That's really where the challenge starts to come in. I think increasingly there'll be more realization of it. Plus, you would probably have frameworks where, if you utilize the frameworks, you get an element of security, almost by design and construction and so on. Those will be things that will kind of enable out. But fundamentally, you have to think about that upfront. You cannot do that in the things there.
Okay. So, so any question from the participants? So this is a very good opportunity for you all to, ask some questions that would have been wanting to ask to someone from the industry. And Mr. Ish here, he is in quite senior roles in his organization, so you can ask questions that you have always wanted to ask. So in the meantime, I have one more question. In a CS or electrical engineering curriculum, how do you think the subject of security should be introduced? Because security in itself is very vast. I mean, there are many sub areas in security to investigate or learn about. But from a curriculum point of view, how and where should one perhaps introduce this thing as a separate course or as part of a module in some existing courses?
I'm trying to reflect on that. I mean, it would be good to kind of do courses on security itself. I think it's a large enough topic that way, but it's probably, useful. So there's approaches to security which, might be useful to have in any of the design courses, right? So as you look at design, it's one of the aspects, right? So we talk about dealing with performance, right? Algorithms that get you higher performance, or designs that get you certain power or performance kind of trade-offs and so on. Security is, yet another key component in that sense, right? I mean, like we were talking about, like we were talking about the various applications out, the security trade-offs are just like the power performance trade-offs, right? So having security as an integral part of the design is probably a good thing to kind of do. Probably there needs to be, the foundational focus. What does security mean? What does secure analysis mean? From the perspective of things like the stride methodology or whatever else, and going through some of the key examples, right? It's not something very esoteric and something that we don't care about. We absolutely care about these things in our everyday life, right? If we see the amount of discourse there is on in the public domain in the aspects of security and privacy, I think being able to make that accessible and understandable and understanding those solutions might be a good thing to kind of do. So I would say having security as part of design curricula and focusing on the fundamentals would be probably a good thing. And then depending on availability of time and resource, getting to advanced things would be certainly a useful stuff to kind of. There's a lot of exciting problems in security, right? I mean, if you look at even if we leave the side of how do you make things secure, if you go about trying to understand how people break in, the black hat attacks in some sense, or how people use voltage measurements to understand some things, or how people use certain kind of data to be able to tell certain other things, or how people have exploited that. I think those could be very interesting things as well, even for the students, right? Because they are nice stories actually, right? And once you build an appreciation of what is possible, then I think we have the smartest students who can figure out how to build a solution. So I think maybe rather than worrying too much about how to solve the problems, we should worry a little more about getting people to appreciate the problems. I think once problems are appreciated, people will solve them. That's just one perspective of teaching and learning in some sense.
So, we have a few questions for you. One is in IoT, especially cyber physical systems, is it required to focus on system level security or OS level security, or both? Something like that.
I think all of the aspects matter, right? And it does matter how secure the system is, the OS is, and so the most important aspect of security is to understand the threat model, right? What is that threat? What are your assets? And how are those assets at threat? They could be at threat because you can. So for example, you could build a really secure software and OS, and you have put out all the information in the clear on the cloud, and anyone can go and access it. That's security that is gone. Or you have a device that is available physically for everybody to be able to use, right? And you have a removable card, and what is stored on that card is not encrypted, right? And so you could, that's where the break-ins kind of end up happening. So it's really important to look at security more holistically and to approach it from the perspective of the threats, and then how you go about mitigating those threats, both from a hardware and software level. I don't know if that address that. Or...
Yeah, I think that understanding of the threat model and that being the starting point, I think that is the way to move forward with respect to analyzing or designing systems. So there is one more question for you, which is there is so much talk that India is one of the leaders in producing engineers, but also at the same time only up to 20% are set to be up to the mark to join industry. So what changes in curriculum or education you suggest that faculty members can share with the youngsters?
So I think, I don't know if there is a standard response to this, so I'll just share my personal opinion in this context. So my view is, I was talking to some young students some years ago and trying to engage on how to maybe approach some of the learning, and what one of the things I found very useful to kind of look at is how things were, say 20 years ago, right? Many of our life, at least our significant learning times would be going back at least 20 years. So 20 years ago to now, how things have changed and how much much of that could have been predicted, right? Typically not very much, right? And what is the past is probably the future as well, right? So a lot of times I see, sometimes industry is looking for people who are just coming ready to be able to come in and plug in and code on a specific thing. I think that's industry's problem. Industry needs to kind of solve that. Sometimes then education institutes are trying to say, oh, that's what industry wants to do, let me make this person ready to be able to go in and run that app, right? But what we really need to understand from a foundational education is that people have to be prepared to be able to deal with the evolution that will happen 20 years down, right? So the fundamentals are really, really important. And a lot of the times, I mean, especially now when so much is possible, you can get Raspberry Pi and you can put 20 things on it and you can get, all sorts of gizmos working in a few days. Sometimes you get this false sense of knowledge, right? When things go wrong or, the space shifts, then we find it very difficult to be able to adapt to things, right? What I think is really important for the students to have is those foundations, right? So like, for example, I was talking about building isolation on top of just these two things, which are, secure and non-secure, right? That's how we do on M. A lot of my day life I spend on the A profile, which is an application profile where you have MMU and so on, and you can be doing that kind of isolation like anything, right? Now, I think it is really important to be able to have people who can transform from saying, this is how I can do things with MMU and this is how I can be doing it using an MPU, and be able to make that transition looking for those similarities, looking for the commonalities and understanding those differences. And enabling students to do that, I think, is the biggest enablement that we can be doing, because that not just enables them to do their job immediately as they get out of college, but it also enables them to do stuff forever. And where people have found fundamentals, when actually one of the guys from IIT Goa has been interning in our team recently, and I think when we enabled him with some level of fundamentals, he was able to make contributions very well, right? Because he spent the time to understand the problem. We also spent the time to make sure that we gave him the space to understand the problem. Then he could solve it because he was equipped to be able to jump onto the things that, in fact, actually, he came from a background where he had not done much programming and we were doing programs and so on. And he picked up that stuff pretty easily, right? Because he was able to appreciate the problems, right? So I think uh, there is a flaw sometimes in the industry of trying to look for people who can come in and log in and start to operate on things. There is also a little bit of a challenge on the academia on sometimes not focusing on the foundation and fundamentals to enable people who can't just solve one thing but can solve a range of stuff, and look for the things there. So I would, at least that's my view. I'm sure I might be having a bit of a minority view in this space, but I strongly keep this view that having the fundamentals is really key. And I've seen that work.
Yeah, no, what you shared is very meaningful and very helpful, and I personally agree with all of that you said. And the student that you mentioned, I know that student because I evaluated him for his mid semester evaluation of his internship. So he did mention to me that you are his direct supervisor is someone else, but effectively that group is under you. So great. So any other questions from the audience? Okay, so if no further questions, then on behalf of IIT Goa, myself, and all the participants here, I would like to thank Mr. Dham for a very nice talk on IoT security, as well as the interaction on how industry looks at education and how how one can prepare students so that they have the basic and the fundamental knowledge. They have learned those aspects properly, and so that they can contribute on a time scale and not just today, and they are not able to contribute tomorrow. So thanks a lot, Aish.
Thank you so
Uh,
much. Thanks very much, Sharad, for the
I
opportunity. I think we
You're
appreciate
welcome, and I hope I'll see you again soon.
it. Sure,
Always.
definitely. Same
Yeah,
here.
yeah, yeah. Thank you, Aish.
Thank you. Take care. I'll take leave. Thank you.
Bye bye. So for the participants, there is something for you. So there is a feedback form that has been sent to me by ARM. Uh, all of you are requested to fill it up. Okay, this is just for ARM, just for not for the FDP. This is just for the ARM talks. Okay, specifically for the presentation and talk by Mr. Dham. Okay, so please fill that up. Then then so let me now first share with you your exam because scores you did not not all of you had could do it by logging in using Gmail account. So scores cannot be released automatically in Google Forms. Otherwise, I would have released them automatically. So your individual scores, I will email you by tonight or by tomorrow, uh, because I will be submitting the details in ATAL portal only next week, not before Sunday. But at the same time, I'll just share with you how your performance has been in the examination. So as a group, how your performance is. And this report I will send to all of you later. So I hope you can see my screen. Are you able to see? So are you able to see this browser window? Okay. So 40 marks was the maximum that one could get. And this is the distribution. So this is more or less a binomial distribution, which, you would, it's a bell curve. I shouldn't say binomial distribution. So the bell curve is here. Okay. And the median score is 28 out of 40. Okay. And there is one person with a score of 39. Okay, which is the highest out of 40. There is some analysis on which questions were missed by how many people. Okay. And then there is all this analysis of individual question of how many people answered it correctly and how many chose. So like in this question, 76 people chose the correct answer, 17 people missed out because here I was capital, here I is small. This was the trick question. Okay. Uh, Here in this question, which of the following is not an open source IoT platform? AWS IoT is not open source. Everything else is open source. So you can see who chose what option. So this analysis of your group performance, that also I will share with you when I send you the slides from today's talk. Okay. And the individual scores I will email to you. Okay. So I will email you your scores. Okay. Individual scores. And then the other thing that I wanted to share with you all is so right now I have shared with you one form above, which is for ARM. So please fill that up. Now in the ATAL portal, you will need to fill up feedback. Okay. Because I think there is some rule which says that there is some policy that you have to fill up feedback form so that you become eligible for getting a certificate. In addition to that, I have a very simple feedback form Just a minute. I have a very simple form for IIT Goa, which we are interested in. So this is a feedback form for IIT Goa. So please fill that up also. If you could not attend the test, you send me an email. You can send me an email. I will schedule a test for you. So, so please fill up this form. So that we get some feedback directly at the end of this FDP. Okay, and now what I would like to do is I would like to, for those of you who are comfortable with the idea, to please turn on your camera so that I can take some screenshots of, right now we see only names on the screen. So I want to take some screenshots so that this can be used for our publicity exercise and our reports and those things. So those of you who are comfortable with the idea of turning on your camera, please turn on your camera. Exam scores, I will email you. I will email individually to you your scores. So can I have some more participants turning on their camera, please? So we have, yeah.
Regarding the feedback form at ATAL portal.
So at ATAL portal, you will have to fill up the feedback form for this FDP. So the formal feedback form that AICTE needs, that you will see in the ATAL portal when you log in. Okay. The feedback form that I have shared now, I have shared two feedback forms. One for ARM that goes straight to ARM. It doesn't go anywhere else. And another feedback form that I have shared is for us, for IIT Goa. It's a very simple form. Okay, so can I have some more, please? We have five of you turning on your cameras. Okay, so I think I'll take a screenshot with. So I hope all of you agree. I'll take one screenshot. Your name should appear. Your image would also appear. It will go in our LinkedIn, Twitter, and other accounts. So thank you to Anjali, Miss Anjali, Mr. Punit. I have an email ID appearing here, so I don't know how to name you. It is okay. It's Dr. Fatima, I guess. Then I think it was Dr. Pooja. So thank you for your turning on your camera. I have taken a screenshot. We have I post these items on LinkedIn as well as on Twitter, so that would all happen sometime this week. Then all the video recordings that I have shared with you so far, by the end of this week, they will all be available on IIT Goa YouTube channel. So once they become available on the YouTube channel, I will send you all the links to all the recordings. So those all session recordings will be available there, and they will be there forever. So you can watch them whenever you feel like. Okay. Now at this point, if you have any questions for me, please feel free to ask. I will answer one question that I saw earlier about some postdoctoral opportunities in IIT Goa. So if the institute does support postdoctoral fellows, currently we don't have any. But if the research proposal for the postdoctoral fellowship is strong enough, okay, if you find a suitable supervisor, it could be in electrical engineering or computer science and engineering, then we will try to see how that proposal can be supported. Okay. Now, any other questions if you have, please feel free to ask me. So I must also congratulate all of you for attending the sessions, and also for interacting with the speakers and asking questions. Next time when we have faculty development program, hopefully the COVID situation would have improved by then, so we will have it face to face. Then you will get to see some of Goa as well if you have not been to Goa earlier. So if anyone has missed the test, please email to me in the next 1 hour or so. I will take your test. Okay. And as far as scores go, I will release you the scores by today, not by today, by tomorrow. And all submissions will only be next week. So if you have any concerns or queries after you have received your scores, you can email me. Okay. So then thank you everyone for your support and also for your wishes. A lot of you have sent me thank you messages. So thanks a lot. It was very nice interacting with you, though I prefer personal interactions, I mean face-to-face interactions. But in this time we couldn't have that. But maybe in the future we will have that. And online, we conduct quite a number of online sessions. So I will share those details whenever we have such a program available. ATAL portal, I would suggest you log into ATAL portal and see, perhaps you can log in as soon as possible and submit your feedback, because I don't know, I'm not aware of when the deadline is in ATAL portal for the participants. Okay. But do remember that for your certificate to be generated, okay, for you to become eligible for a certificate from AICTE, you have to submit at least one feedback in the portal. So please don't miss out on that, okay? So great, then all of you take care, have a good day ahead. And all of you have my email IDs anyway, so if at any point in time there would be, I have been told there is a feedback thing there that anyway you log in and you find it out, okay? Because I can't do a participant login, so I don't know, but some of my other colleagues in other IITs who have conducted they have told me it is there, okay? So yeah, and please fill up the ARM feedback form as well as the IIT Goa feedback form that I just sent to you. So okay, one question, any suggestions for PG students in IoT? What kind of suggestion are you looking for project work, for If you could be a bit more specific, then I will be able to answer your question in a better way. Okay. In general, what I would say, whether the students are at the PG level or at the UG level, if they are taking courses in IoT, and yes, I take BTech interns, so IIT Goa advertises every year sometime in March, April for internships. Okay, so students can apply for internships through an internship portal that opens up in March, April on IIT Goa website, and they can fill up their interest areas and names of faculty members who they would like to work with and things like that. So that is there, that option is there. So there is no project, but it is for internship. Okay, for MCA students, if they do any project under their MCA program, then they can come and spend a couple of months here. Of course, the funding part of it would be a question to be worked out, but whether you have students in at BTech level, at MTech level, or at MCA who have to do some project as part of their degree program, then other than me, also there are other faculty members also here. If they are willing to host the student for 1 month or 2 months, then they can come here. Those options are always available. Okay. Okay, regarding architecture and security of PG students, I would say whether it is architecture or security, they should first read about it. Okay, and if they are MTech students, I guess PG or PhD students, if this is an area in which they want to work, then they should. So we gave examples of IoT OS or OS for IoT systems in the very first day. So they should study how those operating systems are different from Windows or your normal Linux, how they are architected. This will give them ideas of how such operating systems are designed and how they can be improved. And accordingly, they can come up with a project. Same goes for security. So security is at different levels. All of those, whether it is OS level, network level, architecture level, of course, there is also secure bootloaders, trustworthiness in a system. All of those topics are there. But which is the topic that a particular student is more interested in? That can only be found if they do some study. Okay, some readings. So readings are very important. Okay, readings from IEEE transactions, ACM transactions, IEEE conferences, good conferences. Okay. If you don't know which are the good conferences, you can look at my publication list and see where I publish. That will give you an idea of some good conferences and good journals. Okay, I'm also going to update my own website with a list of conferences and journals, which you can read up the material that is published there. A good book for RT projects and programming in Python. Okay, I'll send you the. So when I send all the other remaining course material to all of you, I'll send some book suggestions also. Good. Any other question? So thank you, Mr. Manoj, for wanting to invite me as a resource person in your organization. You can email me, then I can look at my schedule and it can be planned. Okay. So I interact with quite a number of colleges and universities and institutes. Other than my own, yes, all recordings of all sessions will be provided. So all the recordings that I have already shared with you. In addition to that, the remaining recordings. So all those recordings will be put up on IIT Goa YouTube channel by the end of this week. And then I will send you all the links to all those videos. So all sessions which have been recorded, you can watch. So yeah, so for any whichever engineering college, institute, university you are from, if you want to discuss something with me later on, you are free to email me. Okay. Is it mandatory to score 60% to get certificate? I think you should look at ATAL guidelines for participants. That will make it clear to you. Okay. I think there is some guideline. I have not set these guidelines. Okay. But the ATAL ATAL guidelines for participants, that document you should refer to about any such requirement, because the system will automatically generate the ATAL system would automatically generate the certificate. Okay. Anyway, I'm not going to submit this course or anything this week. It would happen only on, today is Wednesday, so only on Sunday or something like that. So if you have any questions or concerns once you have received your scores and you have seen the ATAL guidelines, you can email me. Okay. Any other question? Okay, then thank you everyone. As I said, you have my email ID, so you can email me at any time. Of course, my responses may get slightly delayed. I may not respond immediately, but I will respond. I read all the emails that I receive and I answer all the emails that are genuine emails that I receive. Okay, but my response may be slightly delayed. Yes, you will get answer of the MCQ. Yes, you will get. I will send you the full report after I have taken the examinations of 2 more participants here. I will send the full report to all of you. You can see everything. Without knowing the names of participants, you will see how many people answered what question and what was the correct answer. So you will have all that data. No, you cannot submit multiple responses. As I said, you see your scores first, and then if you have any concerns or anything, you let me know. Yeah, I will share more resources when I send you the full the remaining resources. I'll share. Don't worry. Okay, then I think we will wind up, and all of you take care. It was a pleasure having you all in my FDP. This was my first FDP, not first FDP. This is the second FDP that I am conducting. Last year in December, I had conducted one in IIT Goa itself, together with ARM. This is the second one. First ATAL FDP, the other one was my own FDP. But at IIT Goa, we regularly conduct such FDPs. So whenever we have something in future, please take a look at our website. We announce all of these things on our institute website. We announce these things on our Twitter handle. We also announce these things on our Facebook page. Okay, so at least, if not Twitter, Facebook, at least take a look at our website. Okay, I'll give you the link here. There is a conferences, workshops at IIT Goa section on the website. We announce everything there. Even this course, this FDP is announced there. Okay, in addition to what AICTE did. So thank you everyone, and let's also thank AICTE for running this ATAL FDP program, which has enabled a lot of faculty members and students PG students, scholars, research scholars from all over the country to get together under different subject areas and interact and learn few things. So it's a commendable job that they are also doing. So thank you everyone. Take care and keep in touch. Okay, I will end this meeting now.